so here is the review for our functions and linear relationships. We didn't spend a whole lot of time on this unit, but we are taking it, or we did take a test on this one. So if you're still planning on retaking the test, or maybe you missed a review, here's a video just to help you get through some of the pieces here. So I'll just write, if it'll let me do it. I'll write key at the top here. All right, so we have 4 problems. I'll zoom out just for a second so you can kind of see. So all 4 of these problems are worth 3 points each on the test. There's a really ugly bracket. Better. So they're worth 3 points each. So you get 1 point for domain, 1 point for range, and then 1 point for answering yes or no, whether or not it's a function. So each problem is worth 3 points. So this section right here is 12 points of the test. So 12 out of 22 of the points that are available. So this is definitely a big part to make sure that you understand. And it's a fairly easy part as well. So for domain, when they're asking you for domain, remember domain are the x values. So x values. Whoop. So I'm just going to go through, and whatever they give me, I'm going to look at what are my x values for each one of these. So this is -3, 1, 0, 1, and 5. And then I put the little brackets around it. Little fancy brackets so that it's in the notation. One thing to note is because I have 1 and 1 here, I don't need to put both. I would actually only put 1. I know on the test I was just marking that showing. Other teachers may actually mark you off for that because you didn't list it correctly. So just be aware of what your teachers are expecting. That also tells me, because domain was repeated, that this is not a function. And specifically just because domain was repeated. So I already answered the 2 of those questions. And now I'm going to go through and answer the range question. So range is just my y values. So I'm just going to go through and go, it's 3, 1, -2, -4, and -1. There's no need to rearrange them unless you really, really want to. Fancy bracket. It's a horrible fancy bracket, but try to rewrite those just a little bit better. My fancy brackets aren't doing so hot today, but that's all right. So right there, that's 3 points that I would receive on my test. So the next one, instead of giving it to you in coordinates, it's giving it to you in a table, so XY table, and this is by chance horizontal, so it's going, from left to right. They can also give you a table that's vertical, so it would just look more like this, and then you'd have your X going down on the first column and your Y in the second column. So again, it's just about formatting, but it's all the same information. So this is really easy because since my domain are my X values, and I forgot to write this one down. I said it, but I didn't say it. Range are my Y values. So I'm just going to go, well, here's my X values. So it's -2, -1, 0, 1, and 2. And because nothing is repeated, I don't have to worry about, not including one of those numbers. They're all included. And because domain is not repeated, this bottom one is actually a yes. So I can answer whether or not it's a function just from domain. The range makes absolutely no difference on whether or not it's a function. So yes, it's a function because domain was not repeated. I know a few of you said that you were confused on that one. You thought that if it repeated, then it was a yes. And that's of course, that's backwards on that one. So if it is repeated, then no, it's not a function. If it's not repeated, then it is a function. So that's just a very quick way to do that. So then y's, there are my y. So I go -7, -2, 1, -2, and -7. So with this one, I can see that this is a quadratic. It would make a U shape because it goes from -7 up to 2, -2, up to 1, and then back down to -2, back down to -7. So it's making that kind of U pattern. So just keep in mind on this one, you wouldn't have to put the second -2 and the second -7. You would actually leave those off the list because you only put them in the list once. And again, I'm not necessarily marking students off for that as long as they can show me what domain and range are, but other teachers may mark you off for that. But those being repeated makes absolutely no difference on whether or not it's a function. Only the domain decides that. All right, so now we have 2 of these that are tables on this one. So for domain, again, since it's the x values, I just want to go through and say, okay, well, what's my x value here? So I have to go to the left 3, so that's negative 3. This one is to the left negative 1. This one is to the right 2. This one is to the right 4. And then we have this one is to the right. Oh, I don't know why I drew that line. I'm being silly now. So that one is to the right 4. I didn't have to go up or down at all on that one. To the right 4. And this one is to the right all the way to the side there, which is 5. So that's an easy way to do that. The other way that I've seen students do, which I was suggesting in class, was to literally just put the coordinates next to all these points and then just grab the x's and the y's from them. Because if we know that they're the x values and the y values, it makes it very easy. So this is negative 3, negative 1, this is 2, this is 4, and this one is 5. And then the y values, it's negative 4 for this one. It's going to be my first one. And then this one is up 2. And then we have down again to 4. So negative 4 again, which means that that one's repeated. And then this one is 0 since it doesn't go up or down. And then this last one is up 3. Like that. So, and if you don't list all the numbers, then you didn't finish. This isn't correct. So make sure you list all the numbers or you're going to lose some points there. So I don't see anything repeated in the domain. It goes negative 3, negative 1, negative 2, 4, 5. Or sorry, that's a positive 2, I believe. Looks like a negative 2 because of how I drew that comma. But that was just a comma. Oops. Go back to marker, comma. So nothing is repeated there. So this is a function. Yes. Domain not repeated. The other thing that you can use when you have a graph is the vertical line test. And what this does is it just visually tests whether or not the domain is repeated. So vertical line, whoops, why did it switch to eraser? Vertical line test. And that just means that I'm drawing a vertical line. And as long as my vertical line doesn't cross any more than 1 point, so it cannot cross more than 1 point on any one vertical line, then it passes the test. So this one passes the vertical line test because there's only 1 point per vertical line. Next one. So I'll go ahead and do the points on here like this. So it just takes a second to just go through and list all of these coordinates. So then we have 1, 2, 3, 4. So that's negative 4, negative 2, negative 2. So I can list them as I go, negative 2. And I can already see that that's repeated, which is going to break that function rule. So this one is 1, and this one is over 3. So 3. And again, I know I listed them all, but I wouldn't list the second one. You would leave that off the list. And because it's repeated, you say, no, this is not a function. And you can say domain was repeated. Or, and I can use pink here really quick. Let's see if I can get some pink. Ooh, that's a nice pink. I can see that it's breaking the vertical line test rules. So there's my vertical line. And so vertical line test fail. So this one was a pass. I just didn't write it on there. If that was a vertical line test pass, if I were to draw a vertical line between each one of these, I would definitely have passed this vertical line test because it only passes through 1 point each per line, which is a pass. That one's fine. But if it passes through more than 1 point at even one time, then it fails the test and it's not a function. We still have to fill out the range part here because that's part of it. Oh, that was ugly bracket. There we go, a little better. All right, so we're going down. Let's see, we went over 4 and we went down 5 for that one. So negative 5. And then this one was down 1. This one was up 3. This one is up 2. And this one is down 1. So again, I can see that the negative ones here are repeated, so I wouldn't have put the second one in the list. All right, so 12 points right there, huge part of your test. Definitely make sure that you get those points there because that's an easy part, I think, to get all the points for. So now on number 5, it says given a function, y equals 3x plus 5, find the range if the domain is -4, -1, 2, and 5. So this is the same idea as them giving you a table. If they were to give us, say, a table, just like you can see down below, like here, in number 6 and 7. So it's the same thing as them saying -1, -4, -1, 2, and 5 in a table and just asking you to fill out that table. They're just giving it to you in a list instead of a table. That's all. So we're going to go through, and you do need to show your work on these or you do not get credit. So make sure that you're writing this out so that you can see how you got all of your information, because if you just simply write the answer on the line, you don't get any credit for that. You need to show your work. So you can see I have y equals 3 times -4 plus 5, because I just went over here and I went to my first domain value. And then they want the range, which remember, range is just another way of saying the y values. So y equals -12 plus 5, because 3 times -4 is -12. And then we would subtract these because 12 is negative, 5 is positive. They're opposites. One's negative, one's positive. So I'm going to subtract. And then the bigger number, which is 12, there's more negatives than positives. So I'm going to end up with -7. So that's the first part of my range here. So I can even put that on the list, -7. The next one, if I write this out, y equals 3 times plus 5. So we're going to go -1. So I just moved over here to the -1. Boop, go back. So y equals 3 times -1 is -3 plus 5. So again, one's negative, one's positive. I'm going to subtract. And then the bigger number helps me decide what the sign is. So it says it's +5 and a -3. There's more positives than negatives. So it's going to be a +2. All right, now I have y equals 3 times 2 plus 5. So there's my 2. So I have y equals 3 times 2 is 6 plus 5. So y equals 11. So those ones just add them together. They're both positive. So I get 11. And then I'll put my last one over here off to the side. Y equals 3 times 5 plus 5. So 3 times 5 is 15 and plus 5. So y equals 20. So there's my range. I can put my little fancy brackets around it. I'm not being real stingy about the brackets if you put them on there or not. It's proper notation to put it there, but I'm really not too terribly worried about those brackets. If you don't have enough room to put this all on your test, get a separate sheet of paper and write it out neatly so that we can follow along with your work. You simply saying, I didn't have room to put that on my paper is not an excuse not to show your work. There's plenty of extra paper in the room when you're taking tests. Or you can always ask us if you're not sure where the paper is. All right, so number 6 here. So here's our function rule. So it says complete the function table, then graph the equation. So now we're given a rule, an XY table, and then after we fill that out, we're going to go through and graph it. So you need to show your work while you fill out the table. So this table needs to be filled out. I need to see work, which I'm going to put off to the side here. And then I also need to see 4 graphed lines. Sometimes you won't be able to graph all the lines if they don't fit on the table. But, you know, graphing at least 2, if not 3 of the points will help us know that for sure we have the math correct. And then, of course, drawing an actual line. I had a lot of students graph the points and then not, for whatever reason, draw the line on it. So make sure that you finish that off. So for this first one, I'm going to go y equals 4 times -1 minus 1. So again, I'm just working my way down the table here. So y equals -4 minus 1, because 4 times -1 is -4. So both of these are negative. I still have students who confuse that with 2 negatives make a positive. That saying goes with multiplication or division. Or when you literally see 2 negatives like this. Like if I had 4 minus -1, that's a double negative that turns into a positive. But when I have two pieces, two terms like this, that I'm just subtracting, I just have to understand how to use the integer rules. So this one, I have -4. I'm going one more negative. So in this case, it's going to be -5. And again, you can use t-tables. I know we've been pushing that quite a bit this year with t-tables. So you just draw a little t-table and you go, well, it's -4, it's -1. They're on the same side. So I add and keep the negative sign. And you could have done that, of course, with any of these up here in number 5. All right, next one, y equals 4 times 0 minus 1. 0 in there. So anything times 0 is 0. So 0 minus 1 is just -1. So next one, we have y equals 4 times 1. Whoop, make that blue in a minute. Minus 1. Just so you can see what I'm plugging in there. So 4 times 1 is 4 minus 1. So 4 minus 1 is 3. And y equals 4 times 2 minus 1. So y equals 8 minus 1, which is 7. So this one I'm not going to be able to graph because I already know these graphs are only 5 by 5 in any direction. So I won't be able to graph that bottom one, but yes, you need to have it filled in to get the full credit for it. So let's go through and graph some points here. So we have -1, so I'm going to go to the left, and then I'm going to go down. So -1, so I'm going to go left, and then 1, 2, 3, 4, 5. So it's going to be all the way at the bottom there. So here's my first point. And then 0, I don't go right or left. I'm just going to stay right in the center, but I am going to go down 1, like that. So that goes down. So now I'm going to go to the right one and up 3, 2, 3. And then I can't graph that last one because simply put, it would be off the graph. So it would be somewhere up here where you can kind of see it in line, but you don't have to graph those that are off the line. And then just make sure that you do connect your pieces. Hopefully yours are a little straighter than that. I was trying to do as best I can on my silly iPad here. All right. So this is what you need to do in order to get full credit. I need to see the work, I need to see the table, and I need to see the graph in order to get full credit on this problem. If you make a mistake in the table, generally we just take a little bit of points off, but we don't take all of the points off for that part. All right, let's go ahead and move to the next one here. So I'm going to do the best I can to fit all of this in here without having to use a separate sheet of paper. So y equals -2/3 times, and the first number they chose was -3. And they actually chose these numbers on purpose. So when we have a fraction being multiplied by the x term, we actually want to choose multiples of the denominator, which they did. They have -3, 3, and 6. 0 is always a good option because it zeroes things out, so it makes the fraction go away. But by choosing multiples of that denominator, it's going to eliminate the fraction. So when I go through and I do this, I'm going to have, and I'll write this off to the side here so you can see it, -2/3 times -3/1. And all numbers are over 1. If it's not a fraction, you put a 1 under it. So when I multiply straight across the top and straight across the bottom, I end up with +6 because this is 2 negatives make a positive. It's -2 times -3. And then across the bottom, it's 3 times 1, which is 3, which equals 2 in this case. Now, that's not what I'm going to write in the chart here. That's just the first part. So I have 2 plus 2, so y equals 4. So I'm going to back up just a little bit because I want to give myself as much room as I can here. So 4. All right, so my next one is y equals -2/3. And then I can actually write this one right underneath because this one's going to go quicker. So y equals -2/3 times 0 plus 2. So anything times 0 is 0. So it's going to be y equals 0 plus 2, which is just 2. The next one, we have y equals -2/3, and it's going to be times 3 plus 2. So now this actually is going to react really similar to this other fraction that we just did. The only difference is that I'm going to end up with, darn it, went back to blue. negative 2/3 times just 3 over 1 instead of negative 3. So when I multiply across the top, now it's not two negatives. So I'm going to end up with negative 6, and then across the bottom, 3 times 1 is still 3. So now I'm going to end up with negative 2. It doesn't sound like a big difference, but when I go back over here and I plug this in, that's going to react differently now, because instead of it being 2 plus 2, like we got the first time, now it's negative 2 plus 2. So anything minus itself is 0. So we get 0 here, because negative 2 plus 2 more is 0. All right. Last one, we have y equals negative 2/3 times, and we're going to multiply by 6 this time. 6. All right, so I'm going to do my fraction. I'll do that off to the side here. 2/3 times 6 over 1. So now when I multiply across the top, I get negative 12. And then across the bottom, I get 3. And negative 12 divided by 3 is negative 4. So now I have y equals negative 4 plus 2. And remember, these are opposites, so you can use a t-table if you need to. I know this is getting a little crowded here, but I can go negative 4, positive 2. Whenever I have opposites on a t-table, I bring the smaller number over and subtract, and then I decide the sign by what column they're in, so it's negative 2 in this one. So again, this one, immediately I should have known I can't graph that one because it's 6. It's going to be off the chart, but I can graph the other 3. So I can go negative 3, 1, 2, 3 to the left, and then 4 up. So 3, and then 4. 0, again, I'm not going to move there, but I'm going to go straight up 2, 1, 2. And then 3, I'm going to go to the right and then not move. 1, 2, 3. Because that 0 means I don't go up or down, I just stay there. And then I'm going to go, if I could, I would go to the right 6 and down 2. So it would be, somewhere in that range, maybe right there. But again, you don't need to graph that very last one, simply because it's off the chart. And then remember to connect your line there. Okay, so we're getting through the majority here. We have 2 more of those table ones. So let's go through. So this one we have y equals 3 minus negative 2. So that negative that's in the 2, that negative, does not disappear because there's a negative in the equation. Those are separate negatives, which you can see I've put here as plus minus, which would turn into a positive. So we would have 3 plus 2, which is 5. And then we would do this again, so I'll just write 5. So y equals 3 minus negative 1. So again, that turns into a plus sign. Those 2 negatives, kind of connect them there. So you get y equals 4. And then y equals 3 minus 0. Well, anything minus 0 is just itself. So this just stays 3, right, because it just drops away. And then the very last one, we have y equals 3 minus 1. So this is not minus negative 1. There's no negative on this one. So it doesn't turn into a positive this time. It's just 3 minus 1, which is 2. So that one, the only trick on that one is they threw this negative in to make sure that you were paying attention to that double negative idea. So now I'm going to go through and I'm going to graph these. So I'm going to go left 2 and then up 5. Like that. Get rid of that line that just popped up there. So left 2 up 5. Left 1 up 4. I'm not going to go right or left on 0, but I'm going to go straight up to 3. Oop, one more. And then I'm going to go up 1. Sorry. Right 1 up 2. I'm losing my mind here. All right, so I can definitely see the line that's being created, and I was able to graph all 4 pieces. It's not the best line there. Let's see if I can get it a little less wiggly. A little less wiggly. All right. So there we go, and there's my arrows. All right, last one of these ones, and then we'll move forward. So we have another fraction. I have my denominator of 2. So if you look down here, they chose all multiples of 2 except for 0, which is just, of course, the easy one to choose. So they're doing that on purpose so that when we go and multiply our fraction, they disappear. So we have y equals 1/2 times, and the first number we're going to do is negative 4. So if I come down here and I do my fractions. So I have 1/2 times, for whatever reason, I don't want it to be that color, 1/2 times -4, and I'm going to put that over 1. When I multiply across the top, it's going to give me -4, and when I multiply across the bottom, it's going to give me 2, and -4 divided by 2 is -2. So I have y equals -2 plus 5. Those are opposites, so I'm going to subtract. So 5 minus 2, if I want to rearrange those, is 3. The next one, we're going to have y equals 1/2. And you can also think of this as 1/2 of the next number. If I know that half of 4 is 2, then I've answered that question. I don't have to write out the fractions like I am down below. I'm just showing you what happens to the numbers here when I am multiplying. So now I have 1/2 times -2 over 1. So I'm going to multiply straight across, and I get -2 over 2, which equals -1. So y equals -1 plus 5. Again, I can rearrange these and go 5 minus 1, which is 4. This next one, I'm going to plug in 0. So half of 0. Hopefully you already know that half of 0 is just 0. There is no half of 0. So the only thing left is that 5. So I have a 5 here. And then the very last thing is half of 2 plus 5. So half of 2, it's going to end up very similar to this one, but it's a lot like that one that was on the first page, where instead of it being 1 times -2, it's just times 2. So now I have 2 over 2, which is just 1. So it's y equals 1 plus 5, which is 6. So again, I can't really graph that one, but I filled in my table. I'm going to get my points for that part. So now let me go and graph the other 3 pieces. So I'm going to go left 4 and up 3. Left 4, up 3. Now I'm going to go left 2, up 4. 2, 3, 4. And then I'm going to not go anywhere with the 0, but I'm going to go straight up with the 5. So I didn't go right or left, just straight up to 5. Oh, I just noticed I made a mistake on this one. I scooched over too far. So that very first point, I went over too far, I think. 1, 2, 3, 4. 1, 2, 3. Oh, no, I didn't. It was perfectly fine. All right, so now if I draw a line, pretty darn close. So there we go. I've shown my work. I get all my points for that one, and we're good to go. All right, so number 10, this one is pretty different from all the other ones. So with this one, they're giving you an XY table, and then they're asking you which one of these functions could work with this table. So you could go through and graph these just to figure out which one would work. If you graphed all of these points and then you graphed each one of these just to figure out which one was graphed on the same line. Or you can go through and start plugging in the numbers to see what you get. So if I just start with A, I'm going to start with A. So y equals 2 times, and the very first x they give me is 1. So I'm going to plug in 1. Y equals 2 minus 1. So y equals 1. So that is good. That worked right here. So now I'm going to move to the next number and see if that one works. So now it's y equals 2 times, and it'll be 2 in there. So now y equals 4 minus 1, and that gives me y equals 3. So that did not work. That's not a 4 inside of there, right? So that doesn't work. So I know it's not going to be A. So now let's move to B. So we have y equals 3 times, and we're going to go back to that 1 again. Okay, we're retesting. So y equals 3 minus 2, which is y equals 1. So that's a good one. That one worked here. And now we're going to go to the next piece. Whoop, eraser keeps turning on. So y equals 3 times, and now we're going back to the 2. So y equals 6 minus 2. So y equals 4. Well, that worked. So that one's good. So we can keep testing. So y equals 3 times, And what this one is going to be 3, and then minus 2. So y equals 9 minus 2, which is 7. So that gives me 7. So that works again here. So this looks like it will work out correctly. Go equals 7. So now y equals 3 times, and now we're moving to the 4. So y equals 12 minus 2, which gives me 10, which, look at that, that one works. So this one looks like it's going to be the correct one. It looks like it's going to be B will be our answer. And if you find one that works, you don't have to go and test each of the other ones, but you do want to make sure that it works for every single point. Don't just assume that it works for the other points. Check all of them. Because I do believe all of these work with the first point. They all get you the correct answer. But it's after that that they start to kind of fall apart. So 3 times 5, we get 15 minus 2, which equals 13. And that was our last one here. So each one of these did in fact get us what we wanted. So our answer is B. This one might require quite a bit more work as far as going through. So make sure that you do show all of your work as you're going through the test. Again, if you need a separate sheet of paper, just simply ask for one. All right, so for questions 11 through 16, find the slope of the line, give all equations in simplest form. So first of all, I did have a lot of students kind of forget, this slope of a line is a fraction, so it's a fraction, and it's rise over run. There's only one instance where we wouldn't have a fraction, we would have a word, and that's when we have an undefined slope, and that's when we have something that's straight up and down. We don't say that that's a slope, we just call it undefined. And that's because if you have a line that's straight up and down, we're looking at rise and run, that would mean that the run is 0, and that's the bottom of the fraction being 0, which is why it's called undefined. Simplest form also means that you need to simplify your fractions. Okay, if you don't simplify your fractions, then you don't get full credit. So that's definitely a big piece there. All right, so let's go through and take a look at this one. So if we're looking at rise, and rise is just a way for you to remember that you're going up and down. So if I'm going from this point to this point, from left to right, then I'm not really going to rise, I'm more going to fall down 1. So minus 1 over, I'll go back to red here, and I'm going to go to the right, so that's going to be positive 1, 2, 3, 4. And then I'm done. I don't have anything left to simplify there. So that's it. Just rise over run. As long as it's simplified, you are all done. So we already have a straight up and down line. So you can see this line here. It's going straight up and down. So again, if I were to look at rise and run for my fraction, I would end up, I run 0. I don't go back and forth at all, right? There's no movement back and forth, left and right. But up and down, it's infinite. There aren't points chosen for me because it goes up and down forever and ever. But because of that 0 on the bottom, the only thing that you would need to write here, if it'll let me write it, is undefined. You don't need to show me this part at all. If you just write the word undefined, that is full credit on that question. All right, next question here. So if I'm going from this left point to this upper right point, then I'm going to go, set myself up here. I'm going to go up 1, 2, 3, 4, 5, 6. So that's plus 6. So that's a positive 6. And then I'm going to go to the right 1, 2, 3, 4. So that's a positive 4. So again, if I don't reduce, then I don't get full credit here. So make sure that you reduce and you just simply say, what do they both divide by, so that I can get my full credit. So in this case, they're both even. They can divide by 2. So I just simplify it to 3/2 instead of 6/4. All right, couple more here. We're almost done. All right, so this last one, or this bottom one, sorry, not last one. We're going to, again, I'll actually flip it. I'll go from the top right down to the bottom left, just so you can see it doesn't matter which way you go as long as you're paying attention to your directionality. Make sure you're paying attention to negatives and positives. So if I go from this point to this point, then I'm going to go down 1, 2, 3, 4, 5. And I'm going to go left 1, 2, 3, 4, 5. So they're both negative. So again, I need to reduce this. I can't leave it negative 5 over 5. So I want to reduce, and I'm going to just end up with positive 1, because negative 5 divided by negative 5 is positive 1, which is the same thing as saying 1 over 1. Again, if you left it 1 over 1, I'd probably be fine with that, because you're still showing me the fraction. But you do need to make sure you reduce it down at least to ones. All right, so for this next one, we have our 2 points here. So I'll just go back left to right. For whatever reason, I like going that direction. So we're going to go down. Whoops. Don't know why it disconnected my arrow here. So down, and that was 1, 2, 3, 4, 5. And then we're going to go to the right, so that's going to be positive 10. I can see it's going all the way across. So I went down 5, and then all the way across the graph, which is a positive 10. So again, don't forget to reduce so that you get your full credit here. So both of these can divide by 5. So negative 5 divided by 5 is negative 1. 10 divided by 5 is 2. So instead of leaving it negative 5/10, we write it as negative 1/2. All right, very, very last one here. So with this one, you can see that there is a flat line going straight across here. So again, if we were to think of rise over run, I'm running infinitely, because it's going left and right forever spell that right, infinite? Infinite. But I don't rise at all. I don't go up, I don't go down. So with this case, you don't really have to write this at all. If you recognize that this is a flat line, you would just put 0, or the word 0 is perfectly fine as well. But this is kind of the reason. You run infinitely, but you don't rise at all. And then remember, if you rise infinitely, but you don't run at all, that's undefined. All right, so that is the review for the test. Hopefully that helps you go through and get this filled out. Depending on your teacher, you may be able to use this on your test. So definitely go through and get this filled out, and I hope that helps. I'll see you in the next video.